Perfect. All right. Well, let me first off thank you for taking the time to attend today. My name is Lance Zurich, and I am the product manager for the Fischertechnik division over here at Studica. And today I'm going to provide you with an overview of the Fischertechnik Education Robotic Competition Set. Now, this set's designed to provide students with the tools and the background needed for participating in robotic competitions, and this means whether at the local level or even large-scale national and international competitions. This would be things like RoboCup Junior. Now, more than that, this set was also designed to enable educators to provide students with a project-based, standards-focused curriculum program which involves inquiry, design, and problem solving. Now, the curriculum for this set, like the curriculum for Fischertechnik's two other curriculum-focused project-based sets, those being the STEM Prep 2.0 and STEM Engineering sets, which I might add are the focus of their own webinar presentation. The curriculum for all of these sets was created especially for Fischertechnik by noted educator and STEM expert Tom White, who we will mention later on in the presentation. But anyway, let's get started here. So, there we go. So, what is STEM? Well, of course, most educators are well aware that the term STEM is an acronym that's the letters of which stand for science, technology, engineering, and mathematics. Now, if you're involved in any aspect of education, you probably can't open your email box without seeing the word STEM highlighted in the subject line of at least one of your daily email messages, and you certainly can't read an educational journal or visit an educational conference without being bombarded to references of STEM. The reason for this is really pretty simple. Just to quote the Bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education, STEM education is necessary because it helps to provide the scientists and engineers needed for future development. It provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. As such, STEM education could really be considered kind of a matter of national security. See, on every level, the world around us is changing at a frantic pace. STEM education, it could be argued, enables us, both as individuals and as a nation, to understand and keep up with these rapid changes in technology, changes which in turn are altering the demands and scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments occurring all around the globe, where countries like China and India are making major investments in state-of-the-art infrastructure. And while all of that is well and good, and we should, of course, all strive to be good citizens, many students might also ask, so what's in it for me? Why do I want to study engineering? Why do I want to study coding or what have you? So let's consider what it means on the individual level. First off, a few years back, the United States Department of Commerce released a set of projections for the decade leading up to 2018. Now, these projections indicated at that time that STEM occupations were expected to grow by 17% compared with 9.8% growth for all other occupations. Now, in March of 2017, the Office of the Chief Economist released a STEM Jobs 2017 update, which basically took a look at how those numbers were playing out up until the year 2015, with 3 years still left in this initial projection. Well, what they found was that while the projected STEM growth up to that point, once again 2015, was still a bit less than they expected to reach in total by 2018, by which I mean that it had reached 14% growth at this point instead of 17% the actual growth for non-STEM jobs, which again was expected to reach 9.8%, had instead at this point only reached a fraction of that, 1.7%. A pretty stark difference. Now, here's a statistic I'd like to share that should give anyone entering the job market of the future pause. And this comes from J.D. Chesloff in his Education Week article from March of 2013. Quote, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there is one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on in his article to state, quote, supply is low and demand is high. There is a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. So going back to the STEM Jobs 2017 update released by the US Department of Commerce, which I referenced just a minute or two ago, here are 3 key points mentioned in this report that are well worth keeping in mind when considering the importance of STEM education to the worker. Key point number 1, STEM workers command higher wages, earning, on average, 29% more than their non-STEM counterparts in 2015. Key point 2 relates to the fact that many graduates with STEM skills may not always end up in what are strictly considered to be classic STEM jobs. These would be things, of course, like scientists or engineers or what have you, which we all immediately think, oh, that's STEM. To quote again, STEM degree holders enjoy higher earnings, regardless of whether they work in STEM or non-STEM occupations, end quote. Now, there was a video I saw recently on YouTube posted by the Women's Forum for the Economy and Society, the title of which I think really sums things up nicely, and that title was, quote, every company is a tech company. Now, essentially, what students want to keep in mind is that whatever a company makes, whatever a company sells, or whatever service it performs, at some point, STEM skills are required to help that company fulfill their mission. Anyway, continuing on, key point number 3 relates to job growth, and that is, quote, employment in STEM occupations grew much faster than employment in non-STEM occupations over the last decade, 24.4% versus 4% respectively, and STEM occupations are projected to continue to grow by 8.9% from 2014 to 2024, compared to just 6.4% growth for non-STEM occupations. Well, the trick for educators is to find methods for getting students involved in STEM, and in particular, the most highly in-demand, technology-focused skill areas, and these would be, of course, things like engineering and coding, and to get students involved in a way that engages the students' interest and creativity, but while at the same time developing the work habits, the way of approaching problems, and the skills that they will need to draw on as they move forward in their careers, both academic and, of course, we hope, in their working lives. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur and students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. So how do they do this? They do this through experimentation, through research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on project-based learning. And that brings us to the focus of this webinar, which is the Fischertechnik Robotic Competition Set. Now, this set is one of 3 different standards-focused project-based sets currently available from Fischertechnik. The other 2 sets, you see the 3 listed on the screen right now, STEM Prep and STEM Engineering, are the subject of another webinar presentation, as I mentioned before, so we won't, of course, delve into those too deeply here. Instead, we're just going to focus on the robotics competition set. In any case, each of these 3 sets have been designed to provide a guided, project-based learning experience, complete with detailed curriculum, all of which, of course, uses the unique Fischertechnik building system. And that may beg another question, so what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fischertechnik was created with more of an engineering mindset. Now, what I mean by that is that the core building block in the Fischertechnik system is unique in that it allows attachment from all 6 sides. Thus, it allows for almost limitless design possibilities. Now, many of the parts are also designed to slide together and lock in place, and the hundreds of different parts available will help students to address very specific design needs. Fischertechnik was created back in 1964 by German inventor Arthur Fischer, known for countless innovations used in the construction and the automotive industries. Arthur Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, 1,100 in total. Now, besides Fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949, and he was also the creator of the expanding nylon wall plug, the large example of which you see him holding over there on the right side of the screen, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls or what have you. Now, his company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as various components that are used in the automotive industry. And they also provide consulting services in regards to various manufacturing processes, especially anything involved with automation. Now, I'd also like to mention that Fischertechnik was the very first construction set to offer students the ability to build and program their own robots, and this was using the original pre-Macintosh era Apple computers. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore what we would call STEM-related concepts. These would be things such as robotics, renewable energy, mechanics, optics, physics, pneumatics, and so much more. Now, Fischertechnik has also been used by numerous companies, including companies like Porsche, Daimler Chrysler, and BMW, just to name a few, for industrial simulation and training purposes. Now, in addition, over the last few years, Fischertechnik's line of pre-assembled simulation models have found wide adoption for demonstrating and exploring the world of IoT, which is also known as the Internet of Things, where industrial processes can be monitored and controlled from the cloud. Now, with all this in mind, more than just being something that students are only going to use for a year or two in their development, you can really think of Fischertechnik as being designed so that students can grow along with it. Essentially, as students progress through their academic careers, they can also progress through the levels of Fischertechnik education solutions which are available. So, the Fischertechnik robotic competition set is designed to provide educators with a clear and detailed pathway for exploring the subjects of robotics and coding through the focus of learning how to create mobile robotic models for use, of course, in a competition setting. Now, this set is designed for use by teams of 2 to up to 4 students at a time. It contains 570 components in all of which come packed in a sturdy plastic Gratnell storage box. Makes it easy to store everything, keep it organized. Now, the set is designed to provide all of the materials that you will need, and by this we mean both the physical and the instructional materials, to enable teachers to offer a complete, standards-aligned, curriculum-based, competition-focused class or after-school activity, depending on how you decide to approach it. The curriculum used with the Fischertechnik robotic competition set was created especially for Fischertechnik by a man named Tom White. You, of course, remember I mentioned Tom right at the top of the presentation. See, Tom is a noted educator who's been involved in STEM since the 1970s, and he's known for designing programs for use in educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, this isn't the first time that Tom White has created curriculum around Fischertechnik. Now, besides also being the creator of the curriculum used in our elementary-focused Introduction to STEM series, as well as the long-form curriculum used in the 2 sets I've mentioned previously, the Fischertechnik STEM Prep 2.0 and the STEM Engineering sets, which are designed for use in middle and high school, and higher education as well. But besides all of this, Tom has also incorporated Fischertechnik in many of the educational programs he has designed over the years for other concerns. Now, Tom has often said that he believes that Fischertechnik is the ideal construction set for an engineering-based curriculum program, and he's given several reasons for this. First reason is that he really likes the materials can be used and reused. Things can be built, taken apart, and reassembled into something completely different. He also likes the fact that Fischertechnik is so versatile and the fact that it offers so much more economy than purchasing an expensive piece of equipment. Sometimes he's given me the example of, like, let's say a school purchases robotic arms, with a robotic arm, let's say, where you might perform a couple of experiments, do a few projects, what have you, and then it ends up going on a shelf and gathering dust until the next semester's class has to deal with the same issue. Now, instead, Fischertechnik, with its wide assortment of very specific mechanical and structural parts and components, offers almost limitless creative opportunities to keep using the sets. So you can keep building and doing new things and what have you. And it offers lots of creative options for anybody who's involved in engineering. Now, when Tom White designed the curriculum for our 3 project-based learning sets, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, he'll sometimes say that he sees his own strong point more as being in the creation of curriculum, like we're talking about here, more so than, let's say, conducting a lecture. Well, with this in mind, he focused on creating detailed curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class, so that instead they could focus on the needs of the students. Now, he made sure to include a special tutorial section right at the beginning to familiarize new users of Fischertechnik with how the system works. And he made sure that each section of curriculum clearly spells out how everything will be addressed in that specific unit. In short, he designed the curriculum and selected the components included in each set to essentially act as a turnkey solution that would provide everything teachers should need to deliver the material effectively, and to make sure all that material was in one place. Now, again, the curriculum was designed to provide a clear roadmap for both the teachers and for the students. The goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems and which contain embedded academics. Now, the detailed curriculum included with this set, if followed, provides the basis for what could be a standalone project-based robotics class or an ongoing after-school activity. Now, under this project focus model, students are told upfront what they are going to need to learn and understand. They are given a real-world scenario where they must take on the role of a professional working on a team, which has been presented with a design challenge that they must devise a solution to. And they are then provided with different tools and different pathways to help them achieve this goal. Now, among other things, students must perform research, and this is going to mean research both inside and outside of class. And they have to learn the documentation process, and this will include things like creating a design brief, maintaining a digital engineering journal, and so on. And they're also going to learn about collecting data. They're going to learn firsthand how data acquisition works. They're going to learn how to process data. They're going to learn how to put that data into graphs and other formats, and so on. Now, students are also given a technical literacy task driven by the project. The fulfillment of this task will require them to gain the knowledge and the tools needed to address it through the research and exploration they're going to be doing. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills. They're going to devise solutions to their tasks, and they're going to create prototypes using the advanced Fischertechnik modeling system. Students will then create and install the programs as needed to control these prototypes. They're going to document every step of the entire project, and at the conclusion of each project unit, each group of students will be required to formally present their findings, including a demonstration of the prototype. Now, the curriculum itself comes in the form of a 576-page downloadable PDF document. This document, which we will explore shortly, contains detailed academic material for use in a classroom or after-school setting, as well as full-color step-by-step assembly instructions for building a series of 20 different models. These assembly instructions are included both as part of the PDF documentation and also in a printed physical form in each set. Now, as many educators and students may be new to the Fischertechnik building system, once again, the curriculum PDF also includes a helpful tutorial section at the beginning to help both students and teachers to quickly get up to speed with using the system. Now, this section contains areas such as how to identify the various parts being used, learning how the parts fit together, and even walks the students and the teacher through the assembly of a basic model. Now, the curriculum is divided into 4 main project themes. These project themes or units will focus on competitions, programming, sensing and vision systems, and mobile robotics. Now, the curriculum as a whole is designed to provide enough academic material to cover approximately 70 hours. Now, according to program creator Tom White, there's a little bit of wiggle room here for educators to be flexible with this. And what I mean by this is he essentially pointed out to me that a teacher could choose to leave some things out and use this material to fill approximately half a semester, assuming a daily class period of 50 minutes a day, 5 days a week, or they could add some hours of experimentation to easily bring it up to 90 hours or so if they so chose to. Now, during the course of the 4 project themes, various activities are also addressed and various subjects are touched upon. This will include things like sketching, schematics, Ohm's law and power, an introduction to using the ROBO Pro software, which is the software used to program all of the robots, and an introduction to using the TXT controller, which, as you can guess, is the controller used to control all of the robots. Working with flow charts, open loop and closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch, digital phototransistor, and the digital trail follower, analog sensors including the NTC resistor, the photocell LDR, the color sensor, and the ultrasonic distance sensor, an introduction to using the camera to detect motion, color detection, creating a ball finder, which uses the camera on a swiveling device, working with the line tool, encoder motors, and building the control panel. Now, I'd also like to point out that the curriculum for the Fischertechnik robotic competition set has also been designed to address some of the most widely recognized academic standards that are currently in place in the United States. And this will include things such as the college and career readiness standards for math, science, reading, and writing, the NSES content standards, the standards for technological literacy, ISTE foundation standards, and the next generation science standards. Now, at this point, let's look briefly at some of the actual physical materials included in the Fischertechnik robotic competition set. Now, as I mentioned previously, each set contains 670 parts and components, and this includes, among other things, a license of ROBO Pro graphic programming software, which is designed for Windows-based systems. It also includes one of the powerful and compact Robotics TXT controllers, which has a full-color touchscreen, Bluetooth and Wi-Fi connectivity, programmable sounds, and all sorts of other cool little features, and also includes a fully rechargeable NIMH battery pack and charging unit for powering all of the models. Now, among the specialized components included is a gyro sensor, which is only available in this set. There are also 2 encoder motors, a USB camera attachment, as of course we've touched on, for building robots with vision system capabilities, a phototransistor, an XS motor, 2 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 3 ultrasonic distance sensors, an IR trail sensor, a photoresistor, a reed contact, and of course hundreds of other parts of various types, all of which once again come packed in that sturdy Gratinol storage box. Now, the set also includes some printed materials, such as the full-color 74-page pictorial assembly manual with instructions for building 7 different stationary and 13 mobile robotic models, for a total of 20 models in all. Also included is a printed sample track that you can run the robots on, and a side fence that can be used when we get to some of the exercises. Essentially, even if one chose to ignore the standards-based curriculum, you could still view this as the ultimate Fischertechnik mobile robotics set. The contents of this one box will allow you to build all the models found in both Fischertechnik Robotics TXT Advanced set and the Robo TXT Explorer set. Again, everything students will need to build all 20 robotic models is included right here. And that once again means the programming software, the controller, the power supply, and of course, all of the parts you're going to need. Now, as I mentioned several times that this set will allow you to build 20 different robotic models, let's take a quick look at those models. Again, please note that these are, of course, not the only models you're going to build with this set. In fact, each of the 4 project themes that we're going to look at that comes from the curriculum will really only use these models we're going to look at right now as at best a reference point. And instead, in each of the theme units, the students are going to be required to design and build their own original models to solve the core problem that's being put forth in each of the units. Now, that all being said, this one set will still allow students to build all these models and will include all of the parts as well as the detailed step-by-step instructions for building each of these models, all of which can be studied and experimented with on their own, or they can be used to help students to explore and understand the concepts that they're going to draw upon for their own unique projects. So let me just get a drink and we'll start flipping. Okay. First off, you're going to have an automated ventilating fan, then a temperature control robot that modifies that a bit, an automated hand dryer, a traffic light simulation, and an automated parking barrier. Then you have a swiveling security camera with alarm. Did we skip somebody? Nope. The cameraman, sorry, I thought we skipped him, and a basic mobile robot. Then we go to a hindrance or obstacle detector. Then we go to an obstacle detector with a camera attachment. This allows you to see some of the things that you're going to be avoiding. Then we work with a trail sensor, or searcher, excuse me. Then we work with a detection robot, a soccer robot with movement control, and then we do a soccer robot where the control is right on the robot itself using the vision system to see the ball in the field. Then we also work with a basic tracked model, a trail searcher, using, of course, the trail sensor, a tunnel robot, a color detector for line following, an explorer robot, a rescue robot, and that's an overview of what you've got with the robots you can build. That once again, those are just the core models that are in each set. But as I mentioned, students are going to be building different things as they work their way through. But anyway, at this point, let's turn our attention to the curriculum itself. Now, at this point, as we've already established the themes and concepts the robotic competition set is going to help you address in the classroom, let's now take a look at how the curriculum itself is structured. Each of the 4 project themes focused on in the curriculum for the robotic competition set contains what we would call a roadmap of sorts, where each of the following elements are specifically addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards, an authentic project scenario, a daily teaching plan, supporting activities, and resources. Now here's the table of contents for the robotic competition set. Now the first thing I'd like to note is that the section right at the beginning that I mentioned a few times previously, which is designed to help new users of the Fischertechnik system to quickly get up to speed. Again, the core building blocks on the Fischertechnik system are designed to attach from all 6 sides, and many of the other parts are designed for very specific purposes. Now, this is going to be a little different than the simple stacking construction of many other building sets you might be familiar with. We've included this section right up front, both to increase your comfort with the system and to allow you and your students to get the most from your building experience. For example, there's going to be a section showing how the parts fit together and discussing the pin and groove assembly method used. There's a section showing you how to identify the different parts from the core building blocks to more specialized pieces, things such as clip axles, girders, rivets, angle pieces, and much more. And for educators who are new to conducting a class of this type, there's also a chapter specifically discussing project-based STEM education, because it's kind of a unique concept. Now, after this introductory section, we have the 4 theme units, which I introduced earlier in the presentation. And again, these are competitions, programming, sensing and vision systems, and mobile robotics. Now, in the following slides, I'm going to share some examples from these 4 theme units, and I'm going to bounce around a little bit just to basically show examples of how they address the structural format that I touched upon a few slides ago. Now, first off, each theme unit will start off with a section outlining the purpose of the project to be addressed in that particular unit. Now, this is the section that spells out for students a clear answer to that eternal question, well, why are we doing this? So now you'll have your answer. And it'll also tell you what skills we hope to develop. Now, in the example shown here on your screen, this is taken from the unit on programming. Here, the focus will be on students designing and implementing a program to control an automated system. Now, this is then followed by a section listing the concepts to be addressed in this particular unit. And these are the big ideas that students should learn from that unit and that are going to be useful and vital for them to learn and understand and know, not only for completing the project in that particular unit, but to, once again, to draw upon as they move forward in STEM fields of study and hopefully STEM-related careers. Now, this particular section, which as you'll see on your screen is taken from the unit on competitions, provides an overview of some of the areas students will begin to learn about and explore here. In this case, it's going to be things like control statements, linkages, mechanisms, automated systems, sketching, and so on. Now, after this, in each of the units, is going to be the outline. Well, or I should say in 3 of the 4 theme units, it's going to be found. 1 skips it. But anyway, in the outline, it's spelled out more specifically what will be covered in that particular unit. Now, the example I've got on the screen here is once again taken from the unit on programming. And so you'll see things here listed such as documenting programs, working with object blocks, Boolean mathematics, loops, branching, data, and so on and so forth. After this, we typically enter the section where each of the specific standards to be met by each particular project unit is spelled out, which of course will provide the educational justification for the project itself. Now, we often get asked if our curriculum-based programs meet the standards for a particular state or district, and while we would of course love to be able to state that they do, with 50 states and so many more districts in each, being able to clearly align to all of these individual standards of course, isn't quite practical or feasible. So instead, what we've done is we've selected the most universally accepted standards that are currently in place in the United States. And this means that first we have the college and career readiness math standards, which are followed by the reading standards in literacy, history, and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. Next, we have science standards, beginning with the NSES content standards for K to 12, the standards for technological literacy, followed by the ISTE Technology Foundation standards for students. Now, after this, we'll get into the assessment section, which links to both general course rubrics as well as rubrics related to that specific theme unit. Following this, we have that essential question I talked about. Now, this can be thought of as the major idea to be explored in this unit. Now, in this particular example on the screen, taken from the unit focusing on sensing and vision systems, the question put forth here is how do automated devices sense and interoperate the world they interpolate the world they interpret the world around them. Now, the student scenario for each unit gives the students an opportunity to explore that particular unit's essential question. Now, this is always done in the form of a real-world problem that they're given to solve and answer to where will I ever use this. Now, again, in this particular example, students are told that they are part of a technical sales team working for an alarm company. And to quote from the scenario, quote, "Your company has been trying to increase sales to the museum alarm manufacturers. The decision has been made that sales could increase if there was a web page created that had a section for each sensor, a description of how it works, and a sample alarm circuit that others could use to base their designs on. You will have to build a prototype of the situation your alarm will monitor and list conditions that you will monitor. A section on suggested calibration is also necessary. Your team has been charged with this project. Your team will brainstorm what the web page should contain and how it should be laid out. Your team will conduct internet research to discover how sensors work, what other companies do to create data sheets, and how to create simple web pages using Microsoft Office. Once the research is done and the enabling activities are completed, the team will design their sections for the web page. Any software created for the web pages should be documented completely so another team can easily figure out the work you have done. All work should be documented in the engineering notebook. Students will devise alarm circuits utilizing at least 3 methods. Each sensor will have a page in the manual, and the sample alarm circuit should explain how each sensor works and sees things that the others do not. Students will present their online files along with a presentation of their prototype in hopes of landing a sales contract, end quote. Now, to give an example, in another scenario put forth in the programming theme unit, the student groups will be tasked with designing and building an elevator that will need to function in a particular manner, such as how it will respond to a call button being pushed on different floors at the same time with the elevator stuck in between. Now, in each case, each student group will be tasked with designing, or in this case, each student group will be tasked with designing a programming protocol for how that elevator will navigate such occurrences. And once again, the fictional client's requirements are clearly spelled out, and the students will be required to create a program to address those specific needs. They're going to have to create a physical prototype in this case using the Fischertechnik components, which means in this case they have to build an elevator that meets all those parameters. And they have to prepare a presentation for their clients that includes a demonstration of the prototype and the program they're going to use in action. Now, after we get past that, we go to the daily plan. This was what clearly spells out the expectations as students work through the project in the student scenario. Now, each day of the daily plan acts as a guideline. It spells out specifically what the students are going to look at that day and what everyone is going to need to accomplish. Now, what you'll see is that as different concepts are addressed, students are provided with helpful links which will give them more information. For example, they will have links showing them what's going to be required in the design brief we touched on, or in an engineering journal. Now, once again, each day has a different task that needs to be addressed, a different activity that needs to be performed, or a different question that needs to be answered. In the example now on your screen, again taken from the unit on programming, if you look down on day 7, you'll see that there is a discussion topic, and the discussion topic is, quote, how does my dishwasher know when the dishes are clean, end quote. Which, of course, your dishwasher doesn't know when dishes are cleaned. Instead, a dishwasher is programmed a certain way to go through certain cycles for a specific period of time. And so in here, the teacher can lead a discussion where this idea can be explored and addressed. Now, other things covered in this unit, for example, will include things like how data is taken from a sensor and recorded, how files can be taken from the ROBO Pro format and put into an Excel format to be worked on and then put back into the ROBO Pro format, other things like that. Now, as students work through the daily plan and on their answers to each student scenario, they're going to be required to perform research. They're going to have to do trial and error experimentation, and once again, they have to document the entire process, which again means maintaining a design notebook and an engineering journal. Again, they will design and build a working prototype using Fischertechnik and also create and deliver a presentation of this prototype in action. The curriculum is designed so that each day in the project theme builds on the one before it, and each activity is subsequently more complex, and along the way provides the information they're going to need to draw on to successfully complete this particular project. Now, this really helps to reinforce all the concepts for students, and it also ties everything together in a really organic and meaningful manner. Now, there's also a section at the end of each unit where various additional materials are collected. And this can include vocabulary words, it can include links to carefully vetted web-based resources, it can include Word documents, PDF files, and PowerPoints. Once again, each of the 4 project theme units follow the same structure as we've just seen, including the standards, the rubrics, the daily plan, the resource materials, the links, and so on. And as I mentioned before, there are also numerous links throughout the curriculum for more information on specific topics, which are also collected in one section at the very end of the robotic competition set curriculum PDF. And this includes activity links for things such as sketching, schematic drawings, Ohm's law and power, an introduction to working with the ROBO Pro programming software, and becoming familiar with the TXT controller, a section on working with flowcharts, open loop and closed loop programs, digital branching, logic levels in programs and triggering, logic gates, combinational logic, analog branching, variables, data, sensors such as the digital switch, the digital phototransistor, and the digital trail follower. Then we move on to analog sensors such as the NTC resistor, the photocell LDR, the color sensor, and the ultrasonic distance sensor. An introduction to using the camera attachment is provided. A section on using the camera to detect motion, color detection, using the swiveling camera as a ball finder, learning how to have the robotic models follow a line path, learning how an encoder motor allows for precise control of movements, and building the control panel. And as documenting the entire process is a major focus of the curriculum, there is another section included at the end of the curriculum that spells out the proper procedures for record keeping of this sort. Now, this is designed to help students to develop proper work habits and embeds technical literacy into the projects. This will start with requirements for maintaining an engineering notebook. The elements that make up the design process are outlined. Examples of design documentation are discussed. The problem statement is explained, including its components, the vision statement, the issue statement, and the method statement. Points to be summarized in a design brief are discussed. The elements of testing protocol are outlined. And finally, the components for an engineering report are also clearly outlined. After this is followed by a section containing the step-by-step assembly materials for each of the 20 models, which, as I mentioned, are also included in printed version inside of this set. And that's everything you get and everything you can explore with the Fischertechnik robotic competition set. So just to summarize, the Fischertechnik robotic competition set includes everything you need, all of the parts, the ROBO Pro graphic programming software, the compact and powerful Robotics TXT controller, the rechargeable AccuSet battery pack and charging unit, all the step-by-step assembly instructions for building 20 different instructional models, and complete and highly detailed day-by-day activity, or day-by-day curriculum, excuse me. And the curriculum included in each set is yours to use this year, next year, and we would, of course, hope for many years to come. There are no additional fees. There are no subscription charges for the curriculum. Everything you need is included. Again, each set is designed for use by teams of 2 to up to 4 students at a time, so it's easily scalable. By that, I mean, let's say if we had a classroom of 20 students, you could use as many as 10 sets or as few as 5 sets, depending on your budget and, of course, how quickly you want students to move through the material. Again, it's also all fully reusable. You can build a model, perform the experiments, take it apart, and you build another. And of course, if you ever did need any odd parts or if you ever wanted any replacement pieces, These can be purchased individually in whatever quantity you choose or need directly from the Studica website. Again, the Fischertechnik robotic competition set is designed to make it easy for educators from any background to offer a hands-on, project-based learning experience to their students. Once again, this is what experts agree is one of the most effective methods known for teaching STEM concepts like robotics. Pricing for the set starts at just $6.99 per set, and of course, quantity pricing for classroom size orders is available upon request. So, if you do have any questions, this would be the time in the webinar where you can feel free to ask them. As we will keep things muted, I would suggest if you did have any questions, you could either use the question and answer window on the Zoom toolbar. As I mentioned, it's right towards the middle. Or you can use the Zoom webinar chat window, which, as I said, is at the far right under the ellipses in the Zoom toolbar. So if you did have any questions, you could ask them in there. Or if you like, you can also email me. As you'll see, my email address is up on the screen. That is my direct email address. So if you did have any questions, concerns, what have you, about anything I discussed, any aspect of Fischertechnik's other products, you can ask any of those. My email, as you see over there, is lancez, L-A-N-C-E-Z, @Studica, Studica.com. So just to keep things moving along, because I know we have a lot of stuff going on these days, so I don't want to keep you too long. So going once with questions, going twice with questions. And on that note, I'd like to thank you for taking the time to attend today's presentation. Again, if you'd like to know more about the Fischertechnik robotic competition set or any of our other STEM-related sets, including the Introduction to STEM series for elementary students, the STEM Prep 2.0 and STEM engineering sets, which are once again our other two standards-focused project-based curriculum sets from Fischertechnik, or if you'd like to learn about our line of industrial simulation and training models, or any of the other things we offer, if you'd like to request a quote, or if you'd like to speak to your own dedicated educational representative for your state, you can simply call us at the numbers you see on the screen. In the US, our toll-free number is 888-561-7521, or if you happen to be in Canada, you can reach us at 800-561-7520. Almost the same number, but it's a different office. You can also find more information on all of our products by visiting our special STEM education page on the Studica website, and the address for that page is www.studica.com/Fischertechnik, and that's FISCHERTECHNIK-education. Or you can email us. There are two email addresses you can use. Once again, our general email address for questions is info@Studica.com, or if you have a specific question, once again, about anything I've discussed today or anything in the world of Fischertechnik, you can email me directly at lancez@Studica.com. Once again, thank you very much for taking the time to attend today. Be safe, be well, and have a great afternoon.